Hello guys, welcome back in the multicast video series. So in the last video we had discussed about need for multicast and some use cases scenario, and we have also discussed in detail about IGMP version 1, 2 and 3, and some theory about RPF check followed by PIM. And before proceeding to the next section, here are some couple of quiz questions. So, why is PIM considered protocol independent? And the second question is, which of the following are multicast addresses? I hope your answers are correct. If not, please watch the previous video again before proceeding to the next section. And in the next section, we are going to discuss about PIM Sparse Mode in detail. We are going to discuss about PIM Sparse Mode. So basically, it works on the principle of pull model or the explicit join, which means if you want to receive the traffic, you have to send a join message to the router, which we can understand this behavior by the simple example like if you want to eat an ice cream, so definitely you have to place an order. So similar logic, you can use it for the PIM sparse mode. While coming back, it also uses two kinds of shortest path tree, which is like shortest path tree and the shared tree, while in the case of dense mode it only uses shortest path tree. And sparse mode is like more scalable compared to the dense mode. And shared tree, it is routed towards the rendezvous point, which we also call RP, while the shortest path tree is routed towards the sender. We will understand the analogy between shared and source tree. Basically, tree denotes the path, which means how traffic is flowing from the sender to the receiver. And while talking about the source-based tree, is mostly denote the shortest part between the source and the destination, or the sender or the receiver. And this source-based tree is used by dense mode as well as sparse mode. While talking about shared trees, it is only used by the PIM sparse mode, and it denotes the shortest path from the sender to rendezvous point, and then the shortest path from rendezvous point to the receiver. We'll talk in depth about the sparse mode, basically the working principle of sparse mode. The first step would be it will discover the PIM neighbors, and in the case of if there are multiple PIM neighbors, then it will elect the designated router. And step 2 would be it will try to discover where is the rendezvous point. And the rendezvous point basically denotes the meeting point of sender and the receiver. And once it knows about the rendezvous point, and it will try to figure out where is the sender with the help of PIM register message, and it will also try to gather information about the receiver with the help of PIM join. And once it knows about the sender and the receiver, it will try to build a shared tree between sender and the receiver via RP, and after that it will join the shortest path tree from the sender and the receiver. And once it will join the shortest path tree, it will try to leave the shared tree, and after that in the end it will try to just maintain the multicast routing table. We have been discussing much about RP a lot, but now is the time to understand in depth. So basically it is used as a reference point for the root of the shared tree, and RP learns about the source or the sender via unicast PIM register message. And once it knows about the sender, in the multicast routing table, it's enter S comma G entry. S represents the source and G represents the group. And it also learns about the receiver via PIM join messages. And RP used to merge two trees together, which is shared tree and the shortest tree. There are a couple of challenges we might face if we are not using the RP. So in that case, device or the router, they are not aware of the sender, and even they aren't aware of the receiver as well. So to mitigate this issue, all the router must agree on the same RP address for a specific group. And if the RP address is different in different devices, then in that case, PIM register and the PIM join message are discarded or the rejected. And the way to configure RP addresses in the PIM sparse mode, We can configure it by statistically or dynamically as well. And there are various ways, which is auto RP and the BSR, which is like bootstrap router, which we are going to discuss it in the later section. We'll talk about the PIM register. It is used by the RP to know the sender. While RP should be aware of all the source, that's the reason it is called root of the share tree. So in this case, suppose when the first hop router connected to the sender hears traffic, a unicast PIM register message is sent to the RP. And in the case of multiple first hop router, only the DR will get the register message. So once the RP accepts the PIM register message, it will send the acknowledgement to the sender by saying ping register stop message to the sender, and it will insert x comma g entry in the routing table. So at this point, only the designated router and the RP knows about the source and the group. So and in their routing table, s comma g entry is uh, published. Here we are going to talk about PIM join message. So like in the earlier slides or the video, I have already explained you. IGMP is used for host to the router communication, while PIM is used between router to router communication. So when the last hop router receives an IGMP report, a PIM join message is generated, and it will take up to the reverse path tree towards the RP. So from the receiver, it will take the path towards the RP, and all the routers in the reverse path will install star comma G entry in the routing table and forward the join hop by hop until it reaches to the RP. So at this point, the RP and all the downstream devices towards the receiver knows about star comma G. So once the RP is aware about the sender and the receiver with the help of PIM register message and with the help of PIM join messages, so RP will send a PIM join message towards the source or towards the sender. And after that, all the routers in the reverse path from the RP towards the source or the sender will install star comma G entry in the routing table with the outgoing interface list towards the RP. And once the S comma G entry begins to flow, tree is built end to end through the RP. Talk about the share tree, which is basically the combination of two shortest path tree. It's from RP to sender as well as from receiver to RP. So in many occasions, shortest path tree from receiver to sender may not be the same as shared tree, because shared tree is not optimal forwarding, which could lead us to inefficient network. To mitigate this issue, we always make the last hop router join the shortest path tree towards the source, and it will install S, G entry in the routing table, while it will leave the RPT by sending prune message to the RP. And some of the threshold can be modified with the below mentioned commands. So we will talk about the PIM routing table. So like in PIM dense mode, sparse mode also uses straight refresh method to ensure that feeds are not getting timeout. So after fixed interval or the certain interval, it keeps sending star comma G join towards the RP, and it also uses a sparse prune message, which can be used to speed up the state information timed out if IGMP leave is heard from the end host. So suppose as example, if any host do not want to receive the multicast packet, so it will send the prune message and it will leave the network.